Hello and welcome back to my YouTube channel, your go-to channel for mastering data technologies. Today, we're back with another bunch of interview questions in our series, Snowflake Interview Questions and Answers, Part 26. In this video, we're diving into some advanced and practical Snowflake concepts. We'll explore the handy pipe operator, tackle a scenario involving Snowflake streams, learn how to get warehouse event history, discuss output arguments in Snowflake scripting stored procedures, and finally, list the different types of Snowflake warehouses. If you're leveling up your Snowflake skills for an upcoming interview, or just curious, this video is for you. Make sure you're subscribed and have hit that notification bell so you don't miss any part of this series. Let's jump right in. Question 1. Explain about the pipe operator. Pipe operators are similar to Unix pipe on the command line, but for SQL statements instead of Unix commands. You use the pipe operator to specify a sequence of SQL statements where the output of one statement becomes the input for the next. The pipe operator chains the series of SQL statements together. This greatly simplifies the execution of dependent SQL statements, making your code cleaner and often more efficient. It improves the readability and flexibility of complex SQL operations, allowing you to express multi-step data flows more concisely. It effectively chains SQL statements together. The most common use case is when you want to perform operations on the result of a previous query without needing to store that result in a temporary table or variable explicitly. For example, show warehouses can be piped directly into a select statement using $1 to reference the result. This is a more compact and readable alternative to using result scan of last query ID -1. This is a great feature for quick explorations or for chaining complex analytical steps in your procedures. Here is the scenario for our next question. Now let's look at a scenario that combines tables, streams, and data manipulation. The statements for this scenario are provided in the PPT. We first create a table T1 with 2 columns. Then we create a stream T1_S on that table. Remember, a stream records change data capture events, CDC, on a source table. Next, we insert 2 rows into T1, 1, and 2, 2. Finally, we create a new table consume data from stream T1_S by selecting from the stream T1S. When you select from a stream, it consumes the changes, meaning those changes are no longer tracked by the stream for future queries. If we then run select all from demodb.schema1.t1_s after creating the consumed data from stream T1_S, the query would produce no results. This is because the previous create or replace table as select from demodb.schema1.t1_s consumed all the pending changes from the stream. Building on that scenario, here's our next question. Question 2. What is the row count from stream T1_S after truncating the data from table T1? Think about it for a moment. We've set up the table and stream, inserted data, and consumed the stream. Now we're truncating the base table. Here's the answer. The row count from the stream T1_S will be 2. Why? Because the data was already consumed from the stream before the truncation of table T1. When you truncate T1, it's essentially a delete all operation. Since the stream was consumed, it was cleared of the previous insert operations. However, the truncate operation itself is a new change event on the source table. Streams track insert, update, and delete operations. A truncate is recorded as a delete for all affected rows. So, when we run truncate table demodb.schema1.t1 and then select all from demodb.schema1.t1_s again, the stream now shows the 2 rows as delete actions, with metadata.action indicating delete. This is a common trick question, so it's important to understand the concept of stream consumption and how truncate is recorded. Moving on to the next question. Question 3. How do you get the history of changes, events, for a given warehouse? This is crucial for understanding warehouse usage and any configuration changes. The answer is you can use the Account Usage view, Warehouse Events History. This view provides a record of events and changes that have been triggered for both single cluster and multi-cluster warehouses within your Snowflake account. It typically holds data for the last 365 days or 1 year. A common query for this view is select warehouse name, event name, size, and asterisk from snowflake.accountusage.warehouseeventshistory, where warehouse name is compute WH, order by timestamp DESC. This query will show you events like when a warehouse was started, suspended, resized, or any other significant activity, along with details like the warehouse size at the time of the event. Very useful for auditing and performance analysis. Moving on to the next question. Question 4. Can we use output arguments in Snowflake scripting stored procedures? The answer is yes. With the 9.18 release, Snowflake scripting introduced support for out arguments. When an out argument is specified in the definition of a Snowflake scripting stored procedure, the stored procedure can return the current value of that out argument to a calling program. This could be an anonymous block, another stored procedure, or a client application. As an example, if you define a procedure simple_out_spdemo with an out parameter xout of type number and set xout equals to 2 inside, you cannot simply call it like call simple_out_spdemo of 10, as this would result in an error indicating that a variable is expected for the out parameter to store its value. Instead, you need to call it from a block that provides a variable for the out argument to store its value. A typical call would look like this. Begin, let x:0, declare a variable to hold the output, call simple_out_spdemo of :x, pass the variable with a colon, return x. When this anonymous block executes, the xout value of 2 from the procedure is passed back into the x variable, and the block then returns 2. This is a powerful feature for returning multiple values or specific calculated outputs from your procedures in a structured way. Moving on to the next question. Question 5. Can you list the different warehouse types in Snowflake? When you create a warehouse, you specify the warehouse type. There are 2 main types. First, standard. This is Snowflake's original, industry-leading standard virtual warehouse. It's suitable for most general-purpose workloads. Within the standard type, you now have standard Gen 1 and standard Gen 2. Gen 2 warehouses bring new hardware and software optimizations for workloads that require more performance. This is reflected in the resource constraint parameter when you get the DDL for a warehouse, for example, standard Gen 1 and standard Gen 2. Second, SNOWPARK-OPTIMIZED. These warehouses offer significantly larger memory and cache per server. They are specifically designed for memory-intensive operations, such as those performed by Snowpark workloads, machine learning, and certain data science tasks. While warehouse type is either standard or Snowpark optimized, the resource constraint parameter provides more granular control and implicitly defines these types or generations, especially for Snowpark optimized warehouses. The valid resource constraint values include, for standard warehouses, you'll find standard Gen 1 and standard Gen 2. For Snowpark optimized warehouses, options like memory 1x, memory 1x.886, memory 16x, memory 16x.x86, memory 64x, and memory 64x.x86 are available. Please find the warehouse DDL scripts with different warehouse types for your understanding. Warehouse name, compute WH with warehouse type as standard. Warehouse name, compute WH Gen 1 with warehouse type as Gen 1, standard Gen 1. Warehouse name, compute WH Gen 2 with warehouse type as standard Gen 2. Warehouse name, compute WH SNOWPARK-OPTIMIZED with warehouse type as SNOWPARK-OPTIMIZed. This slide shows all 4 warehouses together with DDL. And finally, this last slide shows different memory configurations and CPU architectures based on warehouse types. It's important to understand these distinctions to choose the right warehouse for your specific workload needs and optimize your Snowflake costs and performance. And that brings us to the end of Snowflake Interview Questions and Answers, Part 26. I hope you've gained valuable insights into these important Snowflake features. From the pipe. If you found this video helpful, please give it a thumbs up and share it with your colleagues and friends. Your support truly helps my YouTube channel grow. Don't forget to subscribe to my YouTube channel for more expert tips, tutorials, and interview prep content. Thanks for watching this video. Keep learning, and I'll see you in the next one.